Right folks, how are we all doing? Thanks again for coming out, and it's terrible weather tonight, but really appreciate you coming out, and I really appreciate Christos stepping up last minute. So thanks a lot for that, man. I'll let you introduce yourself in a minute. I'd like to say thanks to our sponsors, Fuzzy Audios, for our thanks. Andy? NDC,
actually, small.
Oh well. Cheers, man.
Too busy to get anything today.
Also, thanks to our sponsor, Emergent Act, who will be making any announcements either. No, we've got no representatives from them tonight, and One Part Carbon, who I know are at Silicon Mill Roundabout this Saturday in Edinburgh at the Hub. Come along, it's a jobs, tech jobs fair. Loads of other companies there that Emergent Act. One Part Carbon, well, I'll be there, so I'll say hello to you as well. In terms of other things coming up, Scotland JS is in May. The proposals have been accepted, and now can I contact the speakers to see if they're talking. I don't think I'm supposed to tell you, but I've been accepted, so if any of you guys don't mind hanging back after the talk tonight, I'd like to bend your ears on some of my ideas for the talk. It will be 10 minutes. Just to get a bit of a better feeling. But,
so a pint for you buying us all at the Salt Rock?
well, I was going to here. We'll see how it goes. But I don't think we've got anything else to add. So I'll let Christos introduce himself.
Well, thanks for having me at the last minute. The submission of the talk was quite straightforward. We didn't really have to, go through all the vetting and all that. Thanks today for having me, and thanks to you guys for coming today. The weather is absolutely dreadful. My name is Christos Matskas. I am a geek, a developer. I develop for about 10 hours a day. My wife actually has to climb me off the computer, so that's slow. I work as a consultant, so I do lots of different stuff from back-end, server-side applications all the way from front applications like JavaScript and HTML and mobile apps. In general, I love anything that has to do with coding. I've started recently to speak to larger events as well, so thanks for having me. It's fantastic to be with like-minded people. And I love open source. I have a few open source projects on GitHub. Someone's sorry. And that's me. So anything I do with open source, I like. I tweet a lot and I blog as much as I can. My blog is usually about tech stuff or how-tos and solving problems. So, trying to help people. Today we'll be talking about TypeScript. I don't know if you ever come across TypeScript or if you heard about it. It's fairly recent, although it's been in production for about 5 years. And the format of the talk today will be a quick introduction about how TypeScript came about, what's the need for TypeScript, and then we'll do a couple of demos just to see how you can start coding with TypeScript fairly quickly. So, large-scale JavaScript applications are hard to work with. On one of the last projects I worked on, I joined a company and I was introduced to the team. It was a greenfield team. We're going to work on a nice new project. Unfortunately, what I wasn't told about was the fact that we were going to work on a greenfield project that was going to be built on top of a legacy application, which is fine. That every company has a legacy application that everybody is afraid to touch. And that application was actually a Franken project where it was developed over 4 years by so many different teams that in effect nobody knew what it was doing, and the oldest member in the team was about 3 months. It's fine, I mean you can work your way around the code, which is not a problem, but what we came about, and that was really scary, was the amount of random JavaScript that was scattered across the pages. We're talking about thousands of lines of JavaScript and nobody knew what was doing and what was happening. Nobody wanted to touch anything. There were so many Ajax calls in the background, so many callbacks that it was really scary. And I'm pretty sure that I'm not the only one that has been faced with large applications or large-scale JavaScript code. So the idea behind TypeScript was to address the issues that we are seeing today with large-scale application development. Short story about JavaScript. JavaScript was originally developed by Netscape, and it was developed in a period of 3 weeks. They said, right, we need something quickly, we need to respond to the Java platform, what can we do? Right, let's throw that into the mix and let's come up with something that can work on the browser. Netscape browser, that works fine. The original idea behind JavaScript was, you'll probably end up with an application that has maybe a few hundred lines of JavaScript, maybe 1,000 lines of JavaScript. That's fine. But what they didn't anticipate was the fact that it was going to scale out massively into applications that we have today, and we're talking about applications with over millions of lines of JavaScript, which is quite a common occurrence if you work in massive organizations. And as a result of that, you end up with a poor tooling experience, and you can't really scale it. The poor tooling experience, of course, comes from the fact that because everything is dumped into there are a few ways to do it, like you can use prototype and module patterns to increase it, but there are tools like Visual Studio, I don't know if you work with, or Eclipse, they can't really do the stuff that you do in other established languages, like C#, for example, or Java. They have C# and they can offer awesome functionality for refactoring, renaming, go-to definition, find all occurrences of methods or variables, which is exactly what's missing from the current state of mind. And of course, the fact that it doesn't scale means that if you got, you can use namespaces in JavaScript, that's fine, but then again, it's all in the global domain and it's quite hard to work with. And that's where TypeScript comes in. TypeScript is a language that was specifically developed for large-scale applications. Microsoft was the one who initiated the development of the language. And the idea behind it was that it was as a feedback to the problems that the community was facing over the last few years. The biggest benefit of JavaScript is the fact that it's actually a superset of, TypeScript is a superset of JavaScript. It's not a different language, it's not a new language that you have to learn all over again. And when you compile TypeScript, you get the plain old JavaScript that you would get if you were writing it by yourself. That's very important, of course, because that means that any JavaScript that you currently have in your applications can be brought into TypeScript. You can improve the performance of the code, and then you compile it, and then it goes straight into back where it's supposed to be running exactly as you expect it to run. Also, the fact that it's following the exact same mantra of the existing JavaScript means that it will run on any browser, on any host, and any operating system. It's not tied to Microsoft, Windows Server, or it's not tied to Mac OS or Linux. And that's the idea behind JavaScript anyway, running anywhere. And finally, the best part of all, it's open source, right? Anybody can contribute. It's a project that was initiated by Microsoft, but eventually it was opened up to the community. Anybody can contribute and anybody can help out by fixing bugs or improving functionality. Right, so what do we have right now? We have the existing state of JavaScript. You get your JavaScript code, and then you add the awesome features that come with TypeScript, so you get the functionality that's missing. You got classes, you got interfaces, you have modules, you get generics, and you got things like IntelliSense and renaming and all that. So you get the building blocks of object-oriented development in JavaScript, which was one of the things that was quite desired. And then on top of it, at the end, you get the awesome tooling. Yes, it was created by Microsoft. Yes, it works awesomely within Visual Studio because they like it there. But there are awesome plugins for other IDEs. So you get from the basic stuff like Sublime, not so basic, but you get Sublime support. You get IntelliJ support. You got Eclipse support, and there are all new plugins coming all the time. I think they will start supporting Atom soon, which is part of GitHub's development. And in effect, once you put all that together, you compile your application. What you end up is with where you started, you still get your old JavaScript back to run within the browser. Now, as we said, TypeScript is here to offer the stuff that were actually missing when JavaScript initially got developed. So what does that mean? First of all, we have structural typing. It means that you can say, when I create a new variable, I want it to be a string or I want it to be a boolean, and that will be understood by your code within TypeScript, and it will expect a boolean value. If you supply a non-boolean value on a boolean variable, you'll get the nice squiggles underneath it saying, sorry, that's not a value I recognize as a boolean. And out of that, you get also type inference, which means that you can, when you create a method, you know exactly what to expect when the output comes out. You get generics, so you have strongly typed lists, so you have a list of T or a list of students, then you can work with that because you know exactly what to expect out of it. You do still work with the existing libraries that you have, anything that you've already been working on, plugins and frameworks, from AngularJS to jQuery or jQuery UI, anything you want to work with is still there, it's still available, but you can also disregard all that and write your own TypeScript clean code. In effect, it works with other tools really, really nicely. The fact that you have strongly typing and structured typing means that you do get really good tools, and you'll find out as you start working with TypeScript that it's very easy to refactor your code, even on a larger scale application. You get the scalable application structuring. Again, as I said, the building blocks of any object-oriented application. You have classes, you got interfaces, you got inheritance, you have modules, which are almost like namespaces, and you can share code around, which is fantastic. And then the TypeScript supports, it's built on top of ECMA 5 at the moment, but they are really, really working tightly with ECMA 6. And what that means is that classes which will be a part of ECMA 6, for example, as part of the ratification, which I think it ended in December 2014, means that anything that was, anything that is in that ratification will be, or the standard will be supported by a TypeScript, and the language evolves as things evolve. So you got classes coming in a few months. We already support classes in TypeScript. So it's almost future-proof for things that are going to emerge. And finally, it's backwards compatible as well with your existing JavaScript, so there's no problems there. Community is massive. I think at the time that I wrote that, there were about 4,000. There might be about 4,500 posts and code flags. Probably around 200 forks, and the community continues to support that and build on top of the existing TypeScript framework. As I said, the tooling support is quite good. I was almost inclined to do the demo today on Visual Studio, but I thought it's probably unfair because most of you guys are not going to be using it as a day-to-day. So any demos I do today will be on using Sublime Text. Again, you can use Sublime Text on Mac OS. I'm not sure if you can run on Linux, but it runs on Linux and absolutely Windows. Everything that you do is driven through Node.js. So you get the language service, which provides IntelliSense and error checking, and then you have your front end, which can be any ID. And as I said, plugins continue to emerge all the time, and on top of that, you get unit testing with the existing JavaScript tools. At the moment, TypeScript is at 1.0. There is a big roadmap, and it's actually available online, so you can go and check what the roadmap is going to be. There's going to be full support for ECMA 6 when it comes out, and then there will be a wish list on top of that, so people can go and submit requests for new features or bug fixes, and they will be taken into consideration. Again, you can do a pull request and submit your pull request, and it will be taken into consideration when it comes to releasing the next version. I think one last quite big feature is the async await, which is quite big. I don't know if you guys ever worked with C#, but that made asynchronous processing very, very easy. So by defining a method as async and then saying, I'll wait that method until the result comes back, allows you to free up resources, and it makes asynchronous development a lot easier. Right. Demo time. Right. Any questions so far before I get into the demos? No? So Sublime. To work with Sublime, you actually need to create a Sublime solution, and there are a few steps that you need to go through to set up your Sublime to work with TypeScript. As I said, everything is driven through Node, so at the end of this talk, probably tonight, I'll post on my blog a step-by-step instruction set on how to get started with Sublime, because it took me about an evening worth of effort to get it to work. And yes, the fact that you work with open source means that sometimes you might get tools that are not really work exactly as you expect them. And the truth is, I had to go through a couple of plugins to get Sublime to finally do all the things I wanted to do. Not sure why, but it should have been a bit easier to work with. Anyways, so let's get started with. We'll go through the idea of providing just a standard JavaScript function, see how that will translate into JavaScript. As I said, everything that you do in... Everybody can see that? Let me just... So if you Control-B, build, success down here. So that means that our code compiled fine. If there are any errors, and that compiles into a root.js. That's defined in the Sublime solution. If I just quickly show you that. We define the root over here, and we say what kind of functionality you want to have. And one of the options is to define where you want your output file to end up. If you define none, then it actually puts you in the same location as you currently are. So root, that should be that. There you go. So just like that. Output directory there, and the file that will be generated will be exactly the same name as the file.ts, which is the TypeScript extension, and the output will be the same file name .js. Very easy to recognize. So over here, you'll see there's not a big difference between the two files. Actually, there's no difference between the two files. And then if you run it. Sorry. You're paying attention, good. There you go, fine. So let's TypeScript that a little bit and see what we can do. First thing we can check is start typing and code completion. Go back into our TS. As I said, building modules are classes, interfaces, and you got, on top of that, you got inheritance. So over here we define an interface. Funnily enough, you can use interfaces both as a construct or as a contract for your classes, define exactly how you want them to operate. But you can also create variables that are implementing that custom name. So it's a type reference, okay? So in this case, we say I want to create a custom number, which will take a number and a boolean as a cannot operator. And then in the function, we actually hardcode the parameters that you pass. So we expect to pass a custom number and as a first number and second number. And then we'll do a quick check to see if we can actually add these two numbers. So if any of them can be added, then we won't perform anything. And then we'll output the result. Now, one thing that you might have noticed is the optional, the question mark. That's an optional parameter. That's not really a valid JavaScript, but we'll see how that compiles once we build it. See, it's that one over there. Let's try and see what happens. So in this instance, I'm initializing two objects, first number, second number, with a value, and I'm saying that it can be added. And then if we call the function, oh, yeah. Sorry, what's that?
It's in a JS file, is that not TypeScript with the custom number?
And no one should be able to use that test. I'm happy. Free stuff. Oh, really? There's another way. And one cool thing that you can get with TypeScript is they have a live editor. So and if you want to test out without using an IDE, you can just I will show you something. Demo.
Your interface is in the TypeScript.
Sorry?
Your interface is in the TypeScript file. Do you not need to copy the stuff?
Yeah.
Let's go to the TypeScript.
Okay. Another go. We have a custom number. We have a class that implements that. So we have a custom number. Again, it takes a number and a boolean. A custom num class that implements the interface, and then we have two numbers, the add two numbers method. So let's get that. Let's run it. Invalid character. Sorry guys, bad demo. Generics.
Don't worry about it.
Sorry?
It's all good.
Okay, so for generics, again you define an entity. It can be a class or it can be an interface, and then you can create a method that actually takes, takes an array of that entity, and you can sort them out and then return the topmost result, which is no generics here, which is fine. But you can also write that as a strongly typed generic method where you define the type of the array. So this one will say, I'm expecting an object or an entity, a T that extends the entity interface, and then I will perform the same exact operation. But at this point, it already understands what the objects should do. Right. So if we design that.
Sorry.
Yep.
Could you explain line 14 again for me?
Yeah, line 14. Sorry. Right.
So take just all the.
That's fine. You know about generics?
No.
Right. Generics is, say if you have an array of something. In JavaScript, it's very easy to create an array. You just dump objects in there and it will be happily accept that, right?
Yeah.
But what you can do with generics, you can say, I only want to accept objects that implement an interface or a class, or a class. So if you have a student class and you want to define an array of students, you would say array of students,
Yes.
right? That's a generic class, right? So what you can do in your methods, you can say, I want the method to take an array of a specific type. Right? And also you can say, I don't know what the type is going to be at the time. As long as it extends a specific class, then I'm happy to accept it. So you can have a student or you can have a foreign student which extends the object student. As long as that foreign student extends student, then you can pass it as an object. So the genericity of the class means that you can pass any object as long as you have a specific type or implement a type.
Cool.
Right?
That makes sense, huh?
Good.
Just thank you.
So in the first case, this one actually says I'll take an entity. I expect it to be an entity, right? So I want an array with entities only, nothing else. But on the second example, you say I want anything that can actually implement it. If it's a superclass or a subclass, then I'm happy with it. Right. One thing that we said that I haven't shown you yet is the fact that we have IntelliSense. So the entity takes a name parameter, right? So if I take that, say name1, and then build it, we get a nice. I'm actually on the JS file. So if I say building. There you go. So that's your IntelliSense right there. So if you do dot anything, you get that. So it knows it's an entity object. It says I have a name property, so I'm expecting it to get a name. So right, let's run this one. So good, successful button. Let's test that. Create. In this case, I'm going to display. So type inference. What in this case happens for the list of people, the code will do a type matching. So it will try to find based on the initialization, we'll say, do I have an interface or a class that implements that kind of a contract? So do I have anything that has a property name and nothing else? In this case, it says, right, okay, I probably found an entity, and it's going to be quite happy to accept that. So in this case, we have John, Mary, Adam, and Mike. We should see Adam doing that on the result. Sorry guys, there you go. So at the bottom, you see Adam. So in this case, it calls the generics, but let's see how it will run without generics. So We already have a sort by name. It doesn't know what type it is, but it's going to work it out in the end. Again, but the good thing is that you get the flexibility, plus you also have that strongly typed method that's quite nice to work with. Right. I'm just going to show you I think that's the last demo, which is the interface as a contract. So remember, as I said, you can have an interface that can be a type initializer or a type. It can be used as a type variable, or it can be used as a contract, as interfaces should be working. In this case, we have custom number, which implements. Very easy to custom number, and again, it does the same thing as the two numbers. But what you'll also find here is the other thing, that a class can take a constructor and you get the parameters. So you say on the constructor, I want to pass the two variables that will initialize. Now, usually we would write that in this way. So we would say my number. Number is a number, and then we would say can add. It's an optional boolean. And then down here I will say public. And public here. You would have to do the initialization by saying this dot my number equals my number. But rather than doing that, you can shorthand it by saying, if I make this public, and this one public, then you automatically get two benefits. You get one constructor method where it does all the initialization for your object, and you also get the two properties which are automatically created as part of the initialization. And then in your code you can say, when you create a custom number, so in here, if you say first number, can add and my number, so you automatically get access to them, so they become public rather than being private and hidden. Was that semicolon? No. Right. So it always is a semicolon, right? Yeah. So is there anything I left out from the? So we've done plain JavaScript, so you can see how they all look exactly the same. Then static typing. Right. Maybe I've gone a little bit too fast. The idea behind the classes is that once they get compiled into the end JavaScript, it's actually idiomatic JavaScript. It's exactly the same way that you would write a class if you were to create it today without the support of ECMA 6 or TypeScript. So in effect, what TypeScript does, it doesn't try to do something intelligent or work like front page where it used to dump masses of code into your application just to do something. It tries to be very minimal, very Spartan in the way that it writes the code. It doesn't inject anything that you would be writing yourself. So that's one of the benefits that you get with the language. It's almost exactly, it translates to what you would write yourself. And it can only get better as the time goes by, because more and more people contribute to it. And I think that's me. Any questions, guys?
Does it have support for, or does it implement abstract classes at all?
You can create an interface if you want to, and you can use that as your base, or you can have a base class. I think I have a demo for that. Just give me a second. Yeah, I do have a demo. It's called. So you can have class here. It's easier done than said. So do that. So you get your class student over here, which has first name, last name, and then you say, you can say, I want to have a type of foreign student that extends the actual base class. So you get that. Now, a few things to note here. You got extend at the top, which says this object will extend another object, so that's your base class. And then when you want to call something on your base class, you have to use a super, which is a reserved language, reserved word, and in effect that's how you call anything that has to do with your base. So on the constructor, you see we call the super constructor, which is the base object, and also we can call on any method that is exposed from your base class by saying super dot. So if I just that. And you also get full intelligence on all these, so you can see automatically get that say hello, which is the underlying base class. Yeah.
So you may have a student implementing like a person interface, and is that all your other stuff?
That's correct. Yeah, that's correct. That's the premise of object-oriented development with TypeScript.
But does that mean we can't have an abstract class? Because an abstract class means you can't actually create an instance.
No, it doesn't really support that.
I don't think even JavaScript was support that.
No, you can't do that. Not at this stage anyway.
I've just started a new project and I was hoping to start TypeScript in it, but timing wasn't very good for it. The first stumble that I did hit was the very first time I tried to use jQuery inside my TypeScript. And it took me all of 2 minutes to figure out why, but because of the problem of trying to use jQuery in it, where I had to try and find a DTS and try and import that into it, what sort of problems do you have the same issue if you're trying to, say for example you have an existing application and you change part of it, a screen, a section, into use TypeScript, can that still use your other JavaScript? Or do you still have the same issue that you do trying to use jQuery within TypeScript?
No, so you should be, it depends exactly what you're talking about. If you've got a lot of user input event handlers, like are happening on the front end, it's a bit tricky to once you get the hang of it, it's not really that hard. But I have to say that the learning curve is a bit steep, especially when you start on a new project. Especially if you're trying to bring a lot of existing code into TypeScript, that gets a bit tricky. It's easier when you start anew, where you have a clean template to work with, or a clean canvas if you want to work with. But no, you can easily work with JavaScript and jQuery as long as you get a hang of it.
Well, the issue that I had, and I didn't look into it too much, so maybe it's not an issue, but I created a TypeScript class quite similar to what you've got there for just one page I was working on. I then tried to use jQuery within that. It didn't seem to recognise any of the dollar or the jQuery or anything else. I had to import a DTS that I had to download offline, online. And as soon as I did that, it worked. However, I'm not going to have DTSs for any other custom JavaScript that I've written.
No, you shouldn't really have that. No, I think it's the way that you import it. It will be interesting to see how you try to implement that, and maybe I can give you some feedback on that. If I don't see the code, it's a bit tricky.
I think if you run code, if it's in TypeScript, you'll get the IntelliSense, but if it's in JavaScript, you might have to create your own DTS to describe what your JavaScript is, so you get the IntelliSense and compile time checking.
It's the fact that we even compile, you'll get errors because it couldn't recognise things. So you will then, say you had a full application of JavaScript, you wrote this little bit in TypeScript, but it needed something from your existing library. It couldn't compile because it didn't know about it. And I didn't know if it was a case of, yes, you need to create all of it in TypeScript, or if that was something I'm doing wrong. Because to be honest, it was a very short time that I had to play with it, but I had to make a kind of decision very quickly on to go ahead with it.
No, you should be able to work with your existing code. This should be a way. And definitely jQuery, it's one of most of the examples that you see out there, they say these are the benefits you get, and then let's use jQuery to run a few examples. So
maybe a scoping thing, like
I'm not too sure, I didn't have time to look into it too much, I thought it may have been
Okay, it's just for the total boxes. What's a DTS?
Data transformation service.
So what?
Data transformation service, is that correct?
It's,
DTS, is that
it's basically just
a
a-
package or something?
it's basically a TypeScript file which just describes JavaScript.
The definition, yeah.
Alright.
So it's basically a JQ one which describes every function you can have and how you would call it.
So is this to like the compiler?
To let the compiler know what functions are available.
So you write TypeScript to call jQuery, but it doesn't know what jQuery is and what's
Yeah,
in it.
well,
You
you're
then
using
add
it
that
in your
in,
own thing
it
for
knows
that.
what you're trying to call.
Cool. And is there like any kind of, I'm just thinking about some kind of common JS type pattern that we can require in certain files so that we can? I don't know if that.
Yeah, you can import modules,
Yeah.
external modules, yes.
Right
Yes.
at the very top, you have an import for importing your jQuery DTS, for example, which lets all your TypeScript know what you can use within jQuery.
Okay.
I just didn't know how that fitted with your own personal custom JavaScript. Because you're obviously not going to have DTS out of the box anymore, so.
No, I've got also, it's, I'm guessing that module import is well let you hook into these other modules that you may or may not already create. That means you then have that definition of that variable which surely the compiler will know about it then if you've required it in using.
Yeah. Once you've added your reference in, they'll know what.
Yes.
Yes.
The DTS thing, will we have to have that up front, or is that just something so that you can get the organized tooling support?
Sometimes you have to have it so that it knows that variable exists.
Right.
So it knows what the dollar sign actually is.
Probably guess someone will use it.
Is that hard? Have you ever written a DTS file? Is it a simple, hard?
It depends on the size of the application, obviously, because if you got like 4 methods, it's absolutely fine. But I haven't done a large scale one, to tell you the truth. All of the projects I've worked on were more like a proof of concept, just to prove that we can do it. Adoption is quite hard, and especially when you have a massive code base already in place, without any unit tests on top of that, then it's almost impossible to do any changes without freaking everybody out. We said we can prove it, and we're actually working on a brand new project now where there will be a brand new front end, and we are going to be using TypeScript there from end to end.
Is that like a project, without giving away too much, is that project you see quite a large scale JavaScript
Yeah,
project? Is that something
it's going to be quite big. Yeah, it's good.
Is that something you recommend taking into consideration, the size of it? Or the
Size of
Size of the app.
size of the
or
application.
the foreseen size of the application, because we don't really know how these things are going to grow.
It's definitely in the tens of thousands of lines of code.
There's one thing I've noticed with a very small TypeScript class was if you wrote the TypeScript class with your naming convention one way, it didn't like it. So what you would do is change it to what the TypeScript wanted. But when you saved that file, the JavaScript file then had naming conventions that were also wrong.
I think that's based on the ID, because I haven't come across any problems. Where were you coding? What ID were you using?
It was Visual Studio, you would create your TypeScript class with, I get these mixed the wrong way every single time. But basically with your naming structure having the first character being small, your first word.
Okay.
And if
You
you
can prove it, because
did
the
that TypeScript, it didn't like it, wanted you to rename it. But then if you renamed it, the output JavaScript had it in uppercase and the JavaScript didn't like it.
right. So you're saying that if I do that, you won't like it? The compiler that's running over here is exactly the same, the one that actually runs on Visual Studio. It's the TypeScript compiler, which is written in TypeScript, which is fantastic. So what you see over here, whatever you write on the TypeScriptLang.org website on the play area, it's exactly what you should be getting on Visual Studio. Did you use Web Essentials, or did you use the 2013 tools?
It's Visual Studio 2013 I'm using. The only thing I may be thinking is ReSharper maybe causing an issue there.
There you go.
I just thought that there actually it might have to be ReSharper.
You can change the rules on ReSharper just to say, I don't want you to mess with my JavaScript for now.
Well, I normally read the JavaScript to conform to the JavaScript standard, but because it's my first time writing TypeScript and I didn't really play
Right.
it out too much.
No, you should be fine. You should be fine. TypeScript doesn't really enforce any kind of style code rules on your code. As long as you write valid JavaScript, it should be fine.
So when you're debugging your TypeScript, say you're running and stepping through the code,
Yeah.
are you stepping through the JavaScript?
Yes.
Can you step through the TypeScript?
No.
Did you?
Once you compile, you get a JavaScript file, then you run everything through the JS and stuff. The only thing that you get as part of the tooling and support with the IDE, it does send auto completion for your classes, but you can't really do that.
They create map files. No.
Sorry?
You can create a mapping file from the JS to
Yeah.
TypeScript.
Yeah, what is that file? Because it gets created for you.
It's,
I didn't know what it was.
allows you can actually debug in Chrome. It'll show you the actual TypeScript.
Oh, is that what that does, right?
It does the same with like CoffeeScript as well.
Okay.
It's source maps.
I seen it created this random file and I was like, what the hell is that?
They're taking like map files missing or something. Like. So say I use CoffeeScript, I use TypeScript.
Right.
What then CoffeeScript will do is like it does everything in like the immediately executing function. You can see kind of the interface is kind of in that, but the rest below it is not. I was just wondering about like conventions and doing things that does TypeScript do a lot of things like that for you to avoid looking at global scope and anything else. Like CoffeeScript's quite opinionated in what it creates for you.
Yep.
To just try and help you. Is TypeScript like that?
I think what I read from his code up there is you've got the interface side custom num, class custom num. That is all using the anonymous call at the very end. The function he's got that doesn't use it is just a normal JavaScript.
Correct. Yep.
So it outputs as normal JavaScript, which we don't have.
Like CoffeeScript will just put the whole file inside it. But a function just don't want you to put anything in it.
Can't transfer to obviously compile ourselves together.
Is it not?
Use
CoffeeScript not quite strict.
There's a way to expose scoping within same functions. For example, so if you have the same name, or you want to use a name from a different scope within a function, then you have to use a lambda expression, which I don't know, you guys know lambdas?
Yeah.
So you can use a lambda expression to say, I'm actually moving my scope from the outer to the inner. So there is the notion of private and public properties within TypeScript.
What you can also do is, I don't know, I can't remember the terminology, is it modules in this?
Yeah, there is modules.
So it's
you
just
can-
like a namespace and
Correct.
C# Java.
So that's one other thing I didn't speak about was the modules. I couldn't really care too much if you could, but there's no point in such a small app. But the idea is that you have namespaces like you have in JavaScript, but you can import modules and then that gives you a nice scope. So you can say module dot blah blah blah, and that actually creates a nice scope effect. So you don't have conflicts.